Hey, welcome back to another video on YAGSL, and we're going to pick off right where we left off from the last video, where we finish our config files. So once we finish inputting our values in this little template here, make sure you press this download button, as this is going to download your YAGSL configs, and then I'm going to need to unzip this. Extract. Okay. Extract to, yep, okay. So once you have that extracted, we want to go and create our project. I'm gonna delete this. So to create a project, open up your VS Studio, and we're gonna click on this little icon here and go to create a new project. We're gonna use a template, we're gonna use Java, and it's gonna be a command-based robot. We're gonna select which folder you're gonna put this in. I'm gonna put this in my Documents, GitHub, YAGSL projects folder. And then I'm gonna call this YAGSL project. Team member is gonna be your team member. And then we're gonna generate this project. Yes, in current window. Let's see. So we're just gonna let it do its thing. And while we're letting it do its thing, thank you very much. I'll get that sorted later. While we're letting it do its thing, we are going to go open our deploy folder, right? And we're gonna open Review and File Explorer. There we go. And we're gonna need to put our configs file on it. So I am going to go to my downloads. I'm gonna slap this on my desktop real quickly. And then I am going to once again open it back up, Review and File Explorer. And what I'm basically doing is just moving the configuration files we made in the last video into our deploy folder so it can be in our program. I'm going to click on this, and I don't like how there's just like another folder inside a folder. I feel like that's redundant. So I'm going to move Swerve into deploy, and then I'm going to click on deploy again and just basically get rid of this empty folder now. So now if we go back to our VS Studios, we go click on deploy now, it's not empty, it has all of our modules. And that's basically how you're going to import your configuration files into your program. The next step we're going to do is start importing our vendor deps. Okay, so there is going to be a cut here because my laptop did in fact die. But we're going to move on to importing our libraries for YAGSL. Yeah, okay. So we're going to go back to our documentation and go to dependency installation. If we go to this page, it basically gives a list of everything YAGSL requires, basically. Actually, this might be out of date. But in previous years, you would have to basically download all of this on your own. However, this year, if with the new WIP lid update, we can just scroll down after clicking the vendor dependency button and just click install right here. And so then what that is just going to auto install every library that is needed for YAGSL. Although I do have a disclaimer here. This tutorial is going to be a bit before kickoff, is made a bit before kickoff, and so one thing that's missing from this sidebar that I have to do manually, but you don't, is basically download the ThirstyBot JSON on using the link instead. So manage vendor libraries, install online. I have this ready to go. Yep. But basically, ThirstyBots haven't added their library to the WIP libs vendor dependency little tab here. And so by the time kickoff happens, I'm going to assume that they have already added this. And so what should happen is when you import the YAGSL library is that everything here, including ThirstyBots, is just going to auto import. So you see here, you should have 9 installed dependencies. And that should be everything. Make sure everything's up to date and everything is installed. Super easy, super quick. And now we can start making our drive systems, subsystems. So let's go to our main, close our deploy Java, open our subsystem here, and we're gonna copy this example subsystem, and we're gonna paste it in here. Next thing we're going to do is we're going to rename this to Swerve subsystem and basically change everything that's inside the Swerve system to be called Swerve subsystem. That's why it's mad, because it's being called the wrong name. We're going to change that. And we now created our Swerve subsystem. It's time to put some actual code in here. Okay, since now we've just created our Swerve subsystem, we're going to go back into our documentation, and we want to go to the code setup tab and scroll down till we go here. And basically we need to create a Swerve drive using the library or the dependency we just imported, or we've imported. And we're going to copy and paste all these import files first. And we're going to slap them onto the top of our program. It's just squiggly lines because we haven't used any of this yet, but we will. Then we are going to back to here, and we're going to copy and paste this for now. Although I'll tell you we're not going to keep a lot of this, and there are a lot of glaring problems with it. But I'm just going to import all of this just for explanatory sake for now. First things first is going to be that this is missing a semicolon. The second thing here we're going to have to solve is that these are... So basically what it's doing is that this is creating a file called Swerve JSON directory, and then we're going to make a Swerve drive that is going to be using this JSON to create a Swerve drive called Swerve drive. However, if you notice here, these are using 2 different names, which we're just going to change this one to directory for now. And then now that's fixed, you might notice another problem is that there is a unhandled exception type. I don't really know exactly what this means, but I do know how to fix it. So to handle this exception, what we're going to do is just get rid of the problem, as you do with life. And we're going to handle this exception by pasting in this code that I found in the FRC.YAGSL example program. So create this into a new tab. We're going to go to subsystem. There's a lot of code you can just copy and paste here, but I'll try not to copy from too much. But we're going to go to line 102 all the way to line 113 here. And we're going to copy this try to this. Go back here, and we're going to put it inside our Swerve subsystem. And here we go. So what is this trying to do, and why is it still complaining? First things first, this is trying to basically take the Swerve drive that we created up here, and then use that directory that we also created up here. And it is basically saying that use the max speed, know the max speed, and then create a new position with, and then this talk, and then move using translate 2D. So this is construct a translate 2D. X, these will convert and track this meters. So basically, it's tracking your position. And yeah, so this is gonna get this to move. It's gonna catch the exception, and then basically it's gonna throw a runtime error, throw a new runtime when the exception is being caught. And there's some errors here as well as some redundancies in code. First thing I'm gonna deal with is gonna be this. So this is a variable which we are gonna move to our constants folder. Is my charger not plugged in? It's not. Or is it? Huh. Okay. That means I gotta work quickly then. So we're gonna copy this, and then we are going to our constants folder. Actually, we're not copying, we're cutting this. We're getting rid of this in our code. Control X. Going to our constants, we are going to basically public static final. Awesome. We're going to, so now that's gone. Now let's go deal with these three problems here. First things first, it is saying that we do not have a constant called max speed. Reason is, if we go here, we have a constant called maximum speed, which I'm going to call that to max speed, but with lowercases, since I think that's just quicker to type. And so I'm going to get rid of this and put this max speed in here, because that's what's our constant. And I'm pretty sure if you want to change your max speed per minute or per meters, this is how you would change it. Keep it at 4.5 for now. And then meters here, this is basically saying we don't have an import called for meters. So what we're going to do is go back to our example program, and we're going to steal this import from the very top that says import static meters, and then we're going to paste this. I'm going to paste this at the bottom. And that should be our Swerve system basically done. Up next is going to be making our robot container using Swerve input. We're going to start programming our robot container now by using pretty sure it's a new feature called SwerveInputStream, right? I'm going to put this right here. And before we make a command and basically call the command in that robot drive, now we're gonna use SwerveInputStream instead. So first create a Swerve input stream, and we're gonna call this drive angular velocity. Okay, and we're gonna make this equal to a Swerve input stream. Actually, I forgot a step. We need to go up here and basically make a new, we need to make a Swerve subsystem called drive base. So it's going to be a Swerve, Swerve, not that, Swerve subsystem called drive base. And we're going to equal this to a new Swerve subsystem, semicolon. Okay, that makes more sense. And then now when we go back here, we can say and then we're going to go refer back to drive base here. And then we're gonna get Swerve drive. Oh, my brother's waking up. Okay, so there's gonna be error here, but I'm gonna finish typing all this out before dealing with that error because that involves dealing that in a different class. And so I'm gonna put comma there, and then I'm gonna make a new line just for the sake of clean code. And I'm gonna do parentheses, arrow, and then I'm gonna refer to m_driver controller, and then we're gonna get left y, so we're getting the y input, and we're gonna multiply this by -1, comma, and then we're gonna do the same thing. Don't mind it yelling at you. We're gonna go get our controller. We're gonna get the left x value now, and we are gonna multiply this by -1 as well. And then we are gonna end parentheses there, and then we're gonna go enter, and we're gonna get with controller heading axis. Hopefully I can explain this in a bit more detail while I'm not typing this out, as I'm not very good at multitasking. M driver controller, and we're gonna delete this comma for now, and we're gonna get the right. Get right x. Delete this null here. And then we're gonna dot deadband. And if you don't know what a deadband is, it's basically just like the dead zone. So if you have like a drifty controller, or maybe you're making like you accidentally make a tiny little subtle touch to your joystick, it won't automatically register that and send your robot flying. We're going to refer to the we're going to make a constant called deadband, which I'll make that later, and we are going to scale it. So there's going to be a multiplier, scale translation, scale translation of, we're going to do 0.8 for now. Although I'm pretty sure if you want to make your robot, say, move a lot faster, you can change that to like 1 or 0.9. And then we're going to make this so it is alliance relative controls. And we're going to enable that as true. Semicolon. Did I spell that right? Relative controls. And that is alliance relative controls true. Okay. And so you're gonna notice there's some issues here. We're gonna deal with this one first, as this one is pretty obvious. If we go to quick fix, we can create a new constant, and we're gonna call this deadband, and we're gonna change this to 0.05. Right? Oh, it's because it's a string. We don't want a string, we want a double here. So we have a double called deadband, and it's called 0.5. Go back to our robot controller, and now we're going to hover over this, and it's basically going to say that there is no method in our Swerve subsystem that we created up here called driveBase. And basically it's saying there isn't a method that we're calling on, and we're going to have to quick make that. we're gonna create a method. Okay, maybe I spelled something wrong there, but we're going here. Throw. Okay. So we're gonna make a method called getSwerve method. And what we're gonna call is getSwerveDrive, and we are going to return SwerveDrive. Simple. Go back to our robot controller. With controller heading access. What's wrong with you? Return self. Yes. Oh, okay. Just gonna leave that for now, and then we're actually gonna move on to the next step, which is to get the direction. So basically, it's saying this is for the right stick, right? Usually, your right stick is how you're gonna be turning the robot, and so it's kind of mad that we haven't defined what that is yet. So we're gonna call this drive direct. Direct angle, and we're gonna make this so we're gonna take the drive angular velocity and we're gonna copy this, right? And we're gonna take with the heading axis, we're gonna get our driver controller get right x, get right x. Oh no, nope. Like that. And then on our y, it's gonna be driver controller colons get right y. There we go. And we're gonna make it so we have dot while heading while, and then this is gonna be true. Let's see. Maybe I did spell this wrong. Is it? Oh, it's rotational axis. Okay. Did I still spell this wrong? Oh, okay. So, yeah, so this is going to be with rotation axis. This is going to be heading axis. So basically, the turning motion on your right stick is going to be kind of determining how fast you're turning the robot in a sense. And this is basically getting the direction of that right stick so it knows where it's turning, right? Because this here is basically saying these are the inputs. You have your left X, left Y, and then your right X. And then that's determining how fast it's moving, right? And then the angular velocity. And then this here is the angle. So this is basically what direction is it going at. And now you might have noticed that there's still a red squiggly line right here. This is basically a part of one of our imports. And since basically how we're gonna fix this problem is, since we did auto import everything, I guess some of it is not exactly up to date. I don't know if this is all gonna be fixed via from on kickoff, but we're gonna go check for updates, and I'm just gonna click on all of these, select OK, And hopefully when it's done building, this should disappear. But yeah, this is an issue. Maybe I did spell something wrong. Oh, there's a missing A here. Okay. Okay, so I never claimed spelling was my strong suit. And with that, pretty sure that's basically done. Next is we're gonna start making our command. Since now we have our velocity as well as our angle, we're gonna have to make a command to basically like use it. So we're gonna make a command that's comparable. Command drive, and we're gonna call this drive field orientated orientated direct angle, and we are going to basically make it we're gonna use that subsystem that we made, and we are going to call the method drive field oriented, and we're gonna get this, and we're just gonna have the value of the drive direct angle, semicolon. There's gonna be some problems, but that's alright. And then we're gonna make another command called drive field orientated angular velocity is equal to our drive base dot drive field orientated drive angular velocity. Why are you mad? Okay. Spelled things wrong. Anyways, we're gonna have basically two errors here, and if you hover over it again, it's gonna say that there isn't a method for it again. So how we resolve that is we are going to quick fix this, and actually we're not going to do that. Well, actually, you know this works, right? Yeah. Okay. So I'm actually just gonna delete all of this, and we're gonna start a bit more from scratch than this. So we are going to make a drive. So we're gonna make a void. Okay, you know what? I'm just gonna get rid of this whole entire thing, and we're starting from scratch because that was unhelpful. So we are going to make a public void and it's going to be called drive field oriented, and we are going to basically get our velocity from it. Chassis speeds, and we're going to get it velocity. Did I spell this wrong? It's fine. Yeah. Okay. And then what we're going to get here is swerve drive dot drive field orientated, and we're going to get velocity. Put velocity in here. What are you mad about? Is it quick fix? Oh, haven't imported it. Okay, that makes sense. And now we are also, so we've created this. This is basically getting the velocity of our Swerve drive. And now, right, Swerve drive, yeah. We're gonna make another method, because once you have the speed, you gotta do something with it. Command. We're gonna make a command called drive field oriented. That's not oriented. Forgot the E. And then we're gonna take the supplier, and it's gonna be our chassis speed. And it's gonna be the value of velocity. We're gonna make some brackets, and what's it gonna return here is we're gonna crap. Oh, I think that outlet doesn't work. Makes sense. Okay, we're gonna speed this up then. It's gonna return run. Yes. Brackets. Bracket or parentheses, arrow, and then more brackets, and then we put parentheses right here, and then semicolon. Awesome. What we're gonna type in here is swerve drive dot drive field oriented, and we're gonna get velocity, and we're gonna get the velocity. And that's our command. And with that, we are going to, sorry, that's my brother, he's a bit sick. We're gonna basically call all of this and make this our default. So we're gonna make drive base dot set default command, and our default command is gonna be drive field oriented velocity, which is what we have down here. And so I guess I'll keep yapping till my battery dies. But basically, let's recap what we just did. So first, we have our Swerve. We created a Swerve input stream, right? This is new. And we are getting we're using our Swerve subsystem right here. We're getting our Swerve drive, and we're getting these values from our joysticks, our joystick inputs, which is our left Y and our left X, and we're multiplying them by -1, so we're just inversing them. You good, buddy? Okay. Anyways, we're gonna take our with controller rotation axis, so basically the rotation of our joystick on the right here, and we're gonna apply a deadband to all of this of 0.5, which we made in our operator constants. And then our scale translation, we're scaling this all by 0.8. I'm pretty sure we can change this to like 1 or like something slower if you want it to be slower. Keep it there for now. And then this is basically saying that based on which alliance you're on, the controls or how the robot is going to move on the field is going to be different. So you don't have to be, it's like based on your gyroscope, you know. And then down here, we're basically defining what the angle our robot is moving. So up here is our velocity, which is your speed. This is the angular velocity, which means what direction it is going. And you're getting this by based on your right X and your right Y. And while heading true is when that, you know, it's being pushed on. And then here you're calling the command of getting the angle and the velocity that we made in our Swerve system here. So here's the command for that, where we got our velocity. Here's the method of using the velocity here, getting our chassis velocity, and then we have a swerve drive that returns swerve drive. Let's see what else. Up here, this is basically how we handled that exception that you saw in the beginning of the video. And here we are creating a swerve drive that is using the directory that we made, or that we imported. And with that, I think, oh, and one more thing. You basically set that to the default command. And I think that's done. Yeah, so with this, you should have a working teleoperable swerve drive. With this, you can get more advanced, but with PID, as well as using simulations and starting with a autonomous. But I'm going to end this video today, and happy swerving. Okay, here's like a bit of like editor me here. In the tutorial you saw I manually typed all this, but if you are lazy and you somehow skip to the end of the video for some reason, I will say you can technically just copy and paste all of this from the example code. So I'm going to just show you where would you find this in the example code super duper quickly. So in case you're lazy like me and just want to copy and paste rather than manually go through the entire tutorial, you can skip here. So let's start with our subsystems. If you remember those methods we were trying to make, right? If you control F and you go to Swerve, Swerve drive, should be at the bottom actually, here. Down here, basically, you want to copy this method right here, put that into your Swerve subsystem, and then we have our drive oriented, drive field, and that is going to be these two commands right here. You're also going to copy and paste that into your Swerve drive subsystem, and then we are going to, and that would be technically the methods you need to copy and paste. Remember, you still need to copy and paste the exceptions as well as some other things I explained in the video. But that's like the two main things you need to copy from there. We're going to go back to robot. Let's hope this loads, and let's hope my laptop doesn't die. We're going to... robot container, come on. You can do this. Make it to your last leg. Go to your robot container, and then you should be able to find what you saw in the code. Let's see here, input stream. You're going to copy from line 59 right here all the way to 89 here, and that is basically everything you need from your robot container. Just don't forget to make sure you set it to default and set the angle drive to default like you did right here. And also don't forget to remember to create your Swerve subsystem right here. And so if you don't want to type all of this out, you can copy and paste it from the example, although I think it's really nice to just type it out and you can learn the process to it. With that, if you want, that should make your life a lot easier, and yeah, post note done. Happy swerving.